Okay, this is Algebra 1, Lesson 1.3, Solving Equations with Variables on Both Sides. Okay, this is our first example. We're going to solve 10 minus 4x is equal to negative 9x and check our solution. Now this is example 1 in your textbook, so you're just going to listen to the explanation and follow along, and then we'll write down the next example. So we're going to start with the equation. And what we need to do when we solve the variable equations with variables on both sides is we need all the variables to one side and all the constants to the other. So we're going to add 4x to both sides in order to get 10 on one side of the equation by itself, and when we combine the negative 9x and the 4x we get a negative 5x on the right hand side. The next step will then be to just undo the multiplication. So we'll divide both sides by negative 5. We'll simplify, and the solution is negative 2, and then we'll check our work. So always go back into the original equation, not one step along the way. If you go back to the original equation, then you'll be sure that your solution is correct. Okay, this one is for you to try. So the equation is 5p is equal to 24 minus 3p, and we want to check our solution. In this case, I would start by adding 3p to both sides. Okay, that cancels the variable on the right hand side, and 5 plus 3 is 8p equal to 24. Next step, divide both sides by 8, and we'll see that p is equal to 3. To check your work, go into the original equation and substitute in the value of 3. And right here you want to take 24 minus 9. Since we see that that is 15, 15 equals 15, we know that we've done it right. For example 2, we're back to the textbook. Solve 3 times the quantity 3x minus 4 is equal to 1/4 times the quantity 32x plus 56. So the first step we're going to do is to distribute. So we'll distribute the 3 on the left and distribute the 1/4, or divide each term by 4 on the right to get rid of the parentheses. Next, go ahead and let's move the constant to the right hand side of the equation. So we'll add 12 to both sides. Simplified. So now that we have the constant on the right, we want to move the variable term to the left. So we'll subtract 8x on both sides. Go ahead and simplify, and then check your work. Okay, this is your example 2 to write down in your notebook. Go ahead and solve this equation. You want to start by distributing the 2 on the left to simplify to 6n minus 8. Distribute the half on the right hand side within each side, and so we'll get a 5 minus half of n. So the first thing we're going to want to do is move the constants to one side, and I'll go ahead and add 8 to both sides. Bring down the 6n. Will be equal to 13 minus half of n. So then we'll move the variable term to the left. And I'm going to go ahead and change that to a decimal when I add, and I'm going to continue this at the top. So I have 6.5n is equal to 13. So if I divide both sides by 6.5, I find that n is equal to 2. To check my work, I'll go ahead and do some multiplication. Remember, I'm substituting this 2 in for each value of n. So I would have, for the check, I would have 2 times 3 times 2 is going to be 6 minus 4 is equal to 0.5, and 10 minus 2. So 2 times 2 has to be equal to half of 8. So 4 equals 4, and I see that it is checked. Okay, now on to example 3. So let's work through these. So we'll start off with A, and we'll distribute to get 15x plus 6 is equal to 15x. Subtract 15x from both sides and get 6 is equal to 0. You can see that this is never true. So this solution, or this equation, has no solution, okay? You probably sensed something would go wrong once you saw the variable terms. Let's try B. So after you do the distributive property, you can add 8y to both sides, you can simplify, negative 2 is equal to negative 2, and you can see that this is always true. So this equation has infinitely many solutions. Okay, so these are going to be the problems that you are going to try on your own for your example 3. And then we'll go ahead and watch the video.
Solve each equation. Part A. 4 times the quantity 3d minus 1 equals 12d. First write the equation. 4 times the quantity 3d minus 1 equals 12d. Next use the distributive property. Multiply 4 times 3d and 4 times negative 1. 4 times 3d plus 4 times negative 1 equals 12d, which simplifies to 12d minus 4 equals 12d. Next subtract 12d from each side of the equation to isolate the variable terms on one side. Because 12d minus 12d equals 0, negative 4 equals 0. The statement negative 4 equals 0 is never true, so the equation has no solution. Part B. 21 minus 7w equals 7 times the quantity 3 minus w. First write the equation. 21 minus 7w equals 7 times the quantity 3 minus w. Use the distributive property. Multiply 7 times 3 and 7 times negative w. 21 minus 7w equals 7 times 3 plus 7 times negative w, which simplifies to 21 minus 7w equals 21 minus 7w. Next add 7w to each side of the equation to isolate the variable terms on one side. Because negative 7w plus 7w equals 0, 21 equals 21. The statement 21 equals 21 is always true, so the equation is an identity. So the equation has infinitely many solutions.
Okay, good thing this example 4 is in your book because it's very, very small to read. It says a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip only takes 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? So we want to make sure that we understand the problem. We're given the amounts of time the boat travels and the difference in speeds for each direction. So you're asked to find the distance the boat travels upstream. So making a plan, we're going to use the distance formula to write expressions that represent the problem. Because the distance the boat travels in both directions is the same, you can use the expressions to write an equation. So using the distance formula, we get distance is equal to rate times time. So you have your distance upstream equal to the distance downstream. So let x be the speed in miles per hour. So in the equation, we will have our x miles per 1 hour times our 4 hours, and we can see the unit cancellation here. And then that's going to be equal to our x plus 3 miles per hour times the time, 2.8 hours. And again, the hours cancel so that we're left with our units of miles, which will tell us how far it travels. So we can simplify to 4x is equal to 2.8 times the quantity x plus 3. Okay, use the distributive property. Subtract 2.8x on both sides. And last, divide both sides by 1.2. So the solution would be that the boat travels 7 miles per hour upstream. To determine how far the boat travels upstream, multiply 7 miles per hour by 4 to obtain 28 miles. So then look back to make sure, does my answer make sense? Because the speed upstream is 7 miles per hour, the speed downstream is 10 miles per hour. When you substitute each speed into the distance formula, you get the same distance upstream and downstream. And that kind of makes sense to us because the distance that they traveled was exactly the same. Okay, so here's a problem for you to try and write down, and we'll take this step by step and at a little bit slower pace than that first example. So we want to think about what this is telling us. So Paul bikes for 3 hours to reach his favorite beach. He bikes 2 miles per hour faster on the way back. So the trip back only takes 2.5 hours. How fast did he bike going to the beach? So to make sense of the problem, we want to know his speed going to the beach. But we know that the trip to the beach and the trip back are equal to each other. It's the same distance, okay? Only thing he did was change his speed, which then again changed the time. So we'll have two expressions that we can write, and we're relating them to this distance formula. So remember, distance is equal to your rate or your speed times the time. So you have your distance to the beach equal to your distance back from the beach. Okay, let's say he's going home. Okay, so we'll use this rate times time. Now, the last example showed us the dimensional analysis. I kind of like to include that step because it's real important that when you're doing these types of problems that your units are canceling out correctly, because when we have our units left, we want to be in miles, has to be equal to miles because we're talking about distance. So we need to assess a variable, and what we need to know is how fast did he bike going to the beach. So that's what x is going to be equal to. X is going to be equal to speed or rate to beach. Okay? So going to the beach was x miles per hour as his speed times the number of hours it took, and we see the hours cancel, is going to be equal to, now on his way back, he goes 2 miles per hour faster. So whatever his speed was plus 2, so x plus 2 miles per hour, and it only took 2.5 hours. And again, the h's or the hours will cancel out. Okay, so make sure you've gotten that written down, and I'm going to clear it And the next step will be to simplify. So we'll take our rate times our time, so x miles per hour times 3 hours will give us 3x, and then our rate times our time, so we have to use the distributive property, so we'll have our 2.5 times the quantity x plus 2. So let's simplify. Okay. So now, oops, I forgot that variable. Okay. So now we want to go ahead and solve. So I'm going to go ahead and subtract 2.5 x from both sides. So 3 minus 2.5 is going to give me a decimal on the left is equal to 5. So if I divide both sides by that decimal, I get x is equal to 10. Now this 10 is equal to my miles per hour. He traveled 10 miles per hour. So how fast did he by going to the beach? The answer is 10 miles per hour. Okay? Now how do we check our work? Well, if he traveled 10 miles per hour for 3 hours, that's a distance of 30 miles. If he traveled 10 plus 2 miles per hour for 2.5 hours, that's also equal to 30 miles. So we did check our work to make sure that it is actually the same distance for both. Okay, here's your assignment. You'll find it on pages 23 to 24. You're going to do all of numbers 3 through 21 and then skip a few and do number 33.